Okay, all right, now, what we're going to be doing today is we're going to be looking at some other methods that are used for solving systems of equations. Okay, and the first one that we're going to talk about is talking about an augmented matrix. An augmented matrix. Now, what has been going on while you've been doing the matrices is that you've been using x's and y's. And as we get into the next chapter, in I think it's 4.8, you're going to have x's and y's and z's. Right? And so there's a lot of letters, variables that have to be written. Well, in mathematics, if we stay with the x's in the first column, the y's in the second column, and the z's in the third column, we can actually skip writing those letters. And that's what an augmented matrix is. And so if we were to look at these two, right, and we were to try to make a matrix, we would have what number to begin with? 1 followed by 3 followed by 1. In the second row, negative 3. Negative 15. Okay? All right, now, I want to talk about a certain type of matrix. All right, and that is called, oh gosh, I just lost the name of it. Identity, thank you. Lord. I-T-Y, is that right? Identity. Okay, an identity matrix has a 1 followed by zeros, followed by a number. This is for x, y, and z, and then a 0 followed by a 1 and a 0 and a number, and then a 0, a 1 followed by a number. Now, if we interpret this identity matrix, what's the first column? That is the coefficients of what variable? X is the answer. This is the x's. What's the second column?
Y.
The y's. What's the third column? The z's. The fourth column is the number. Right? So this says 1x equals that number. Isn't that what we're trying to find out? What does the second row say? 1y equals that number. And the third row says 1z equals this number. Right, now, those of you that have taken some of the tutoring that we did last week, we worked with this column, didn't we? We got a 1x in the first equation, and then we created 2 0x's underneath it, and then we did Kramer's rule on the remaining. Okay? Well, if we were to continue working the manipulation and got to this identity matrix, then we would have the values for x, y, and z from the mathematics that we did. Okay, so let's look at that just briefly with this 2 by 2. Okay, now, if we were going by elimination, can I eliminate the y's? What happens if I add the 2 equations together? I get 0 for the y's, right? So what happens when I add these 2 numbers together? Negative 2x equals, add these 2 together. Negative 14, that means x is 7. Right? Because negative 2 times 7 equals negative 14. Okay? Well, this already has a 1 in it, and this has a negative 3. And then I have a 3 and a 1, another negative 3 and a negative 15. Alright, so this is my augmented matrix. Sometimes you're going to see them put a dashed line or a solid line between the variables and the number of the answer. Okay? Now, for my identity, I already have a 1. What do I need here? I need a 0. Well, what happens if these 2 get added? 0. But I got to get a 0 here first, because if I add these 2 together, I'm not going to have a 1 in the first place. I'm going to end up with a negative 2. So I need to get a 0 here. Right? How do I get a 0? I have to add a positive 3 to this negative 3x. So I'm going to multiply the first row by 3 add it to the second row, and make a new second equation. Okay? That's the skill that you're learning, right? So I put this here so I can see it. So what is 3 times 1 minus 3? 0. Well, I still want my original. Now I have a 0 here in the new equation. Now what is 3 times 3 minus 3? 6. And then 3 times 1? 3 minus 15? Negative 12. Okay, so now I have two new equations. I have x plus 3y equals 1, and I have 6y equals negative 12. Now you should see this and know what are these two numbers, how are they related? What times table are they both in? 6. So if I divide this second row by 6, I'm going to have 1 and negative 2. Right? So that means I have 1, 3, 1, and then I have 0, 1, and negative 2. Now what does this mean? It means y equals negative 2. And now what I've got to do is I've got to make this 3 into 0. What do I add to 3 to make 0? So therefore I have to multiply this row by negative 3. What is 0 times negative 3? 0 plus 1 is a new 1. Alright? What is negative 3 times 1 plus 3? That's 0. That's what we did on purpose. Now, negative 2 times negative 3. Positive 6 plus 1. 7. And then 1. Alright, so what does x equal? 7. What's y equal? Negative 2. Alright. Now, that's the skill with a 2 by 2 equation with two variables, right? But it demonstrates how to find the identity. Now, we have other skills that can find those two answers. Right? But to learn how to do the manipulation of the equations with a 2 by 2, or in this case with 3 numbers, right, is how you learn how to manipulate so that when you have a 3 by 3, you can end up with the same answer. Okay? Does that make sense? Mm-hmm. Okay, so what we're going to look at is how to do that again. Okay, so I'm going to erase all this, and let's see if you can figure out, oh, I shouldn't erase that one. Too bad. Sometimes you make a mistake. Okay. Alright, here's two equations. Alright, now, what is the original augmented matrix that we're going to use that you're going to write down on your paper?
Negative 5, 1, and negative 2.
Negative 5, 1, and negative 2, and then
negative 3, 6, and negative 12.
Negative 3, 6, and negative 12. Okay? Okay, now, this one is not really going to be helpful if we're going to try to get a 1 for the x. But can I get a 1 for the y? I already got it, right? So, what I can do for my identity is I can do this. Alright, does that make sense?
Yes, yes.
Okay, what am I doing? I'm just switching where the 1 was and the 0 was. Alright, because I already have a 1 here. Alright, now, the next thing you have to do is you have to get a 0 under the 1. So what do I have to multiply this top equation by so that when I add it to the bottom, I end up with 0? You better multiply it by negative 6. Alright? Because negative 6 plus 6 is 0. Alright? Okay, so we're not dealing with the top equation right now, so I'm going to copy it. But when I multiply negative 6 times negative 5, I get what?
Positive 30.
Positive 30, thank you. Positive 30 subtract 3 is 27. Now, negative 6 times 1 plus 6 is 0. And then negative 6 times negative 2. 12 plus negative 12 is 0. So this says 27x equals 0. If I divide everything by 27, I get negative 5, 1, negative 2, and then 1, 0, 0. And so I'm finding the start that x equals 0. Now, how do I get a 0 here?
Divide everything by 5?
Or no, multiply this row by 5.
Right.
Multiply this row by 5, and I like to add it so that I see what I'm multiplying. So 5 times 0 plus that is negative 2. 5 times 0 plus that is 1. 5 times 1 plus negative is 0. And then my last row was this. So now what does this say? It says x equals 0 and y equals negative 2. Okay. That's using augmented matrices. Okay.
What is the x equal?
You tell me. This is, okay, this was x, this was y, and the last row was the number. So this says 1x equals what, Sydney? What does x equal? What's that number? 0. And this says 1y equals what? Negative 2, yeah. Okay, because what I didn't write was this. See, I just stopped writing those numbers. Okay, does that make sense now?
Yeah.
Okay, see where it's coming from? Okay. All right, so let's try another one. That time I didn't erase it. Okay. Let's see if how do I get there? Oh my. I can get up and down. Why can't I see it side to side? There it is. Okay. Oh, look at there. All right. So I need to move this over.
Look, there's already a 1 in the spot.
There's already a 1 in the Y spot. Yes, okay. All right. So go ahead and try this one. All right, so it looks like you're going to use this augmented matrix, this identity matrix up here, because we have a 1 in the Y, and so that makes more sense. Okay. All right, Ruben, what's the original matrix going to look like without the Y's and the pluses and the equals? Wait a minute, no, you're not going to have the X.
I need negative 5.
All right.
1 and negative 3.
And negative 3. And the bottom one?
X, negative 8.
No.
I need 3, negative 8, and 24.
And 24, very good.
Beautiful.
Okay, that's what you start with. And then we already had the 1 there, so then the next thing you have to do is you have to deal with this.
Make it a 0.
You have to make that 0. That's the trick. Is that underneath the 1, you need zeros. And that's what we did, those of you that had the tutoring, that's what we did with the 3 by 3. Is that we got a 1 in the top spot, and then we made zeros underneath the 1. Okay, so, Carissa, what are we going to multiply this top row by so that we get rid of that negative 8? Very good. You're going to multiply by positive 8. And so you just do all 3 of them and write a new second line. All right, negative 8 times that, negative 24 plus 24, we got another 0. All right, 8 plus negative 8 is 0. And then negative 40 plus 3 is negative 47. But boy, aren't we glad that's a 0. Okay? So when I divide by negative 47, that ends up being a 1. Okay, what's left? What's left to get the identity? I got to get a 0 here. All right, Sydney, how do I do that? How am I going to get a 0 here?
You multiply the bottom row by 5.
Very good. That's exactly right. You should have said that as a statement. You multiply the bottom row by 5. Right? Okay? And when we do that, in this problem, the only thing that's going to change is that's going to become 0. All right? So now, what's x equal? X equals
0.
and y equals
-3.
-3. Now, for these, so now the question is Kramer's rule faster or slower than doing this? If you have the 1, I think this is faster. Right?
Yeah.
If you can't create the 1, then Kramer's rule is probably faster. Okay?
Can we use Kramer's rule on these without it being...
Well, let's try it. Let's try it. All right, Kramer's rule, okay, for the denominator, I'm going to say negative 5 times negative 4, which is how much? 40 minus 3. 37. All right, now, this one I'm going to have negative 3, 24, and then 1, negative 8. And I can't do that one in my head, but I did bring my calculator today. Okay, so for Kramer's rule, Ruben, have you done Kramer's rule in your class?
Yes.
Good, good. All right, negative 3 times negative 4 is 24. Subtract 24. That's 0. X is
0.
yay. So it does work, doesn't it?
Yay.
Okay. And we can do the same thing and find the y too. Okay, yes.
But if it's not specified, can I use Kramer's rule instead?
Yes.
Good times.
Yes, you could. You
Well,
could
you
use
specify
Kramer's rule,
what-
and see that's the key on like the SAT test. That you're looking for the solution where the two lines cross. That's the x and the y they have in common. So Kramer's rule will work. This will work, and using the old elimination method where we have the x's and y's would also work, right? But if you're trying to find the solution point, then whichever one you see and you can do, then you can use it, right? Okay, so that's a good question.
On the next quiz, will it specify Kramer's or this, like, or the augmented matrix?
They're gonna ask you to do this by the augmented matrix. Okay? If it were a multiple choice test, then what you would have would be the answers. Or sometimes to shorten it, they would say, what is the x coordinate of the answer? Right? And then you wouldn't have to do both of them, but after you find the values, then you're going to pick the correct answer. So in a multiple choice test, you're probably going to be able to use any method that you see. Right? But what we're going to have on the next chapter test is it's going to ask you to prove that you understand how to do the augmented matrix. Okay? Now, because the augmented matrix on a 2 equation and a 3 equation, the method is the same, right? If you have 3 equations and 3 variables, the length of time it takes to get that is longer, right? That's the reason that I showed you how to get the zeros, how to start with the identity, and then once you get the 2 by 2, use Kramer's rule because it's much faster to make the combination, right? But if you know how to do the 2 by 2, then you could do the 3 by 3, except it's going to take you longer. right? And I was telling somebody today that normally a 3x3 takes a full page of notebook paper to do one problem. If you make one arithmetic error, that arithmetic error carries all the way till you get to the end of the problem and realize that the answer doesn't work. All right? So you can know how to do it correctly, but if you make one silly mistake, you won't come up with the right answer. All right? And so for me, that's really hard, because if I'm grading your algebra ability, I can give you a check, or I can give you credit for being able to do the work, but you just didn't come up with the right answer, so you lost 15 points for not coming up with the right answer, as opposed to getting a 0 because you got the wrong answer.
Right.
So to me, that's a whole lot more fair.
Right.
Right? So I don't know what we're going to see when we get to that test. Right? But that's the way, that's where you will get some extra credit if you don't come up with the right answer, provided you show me the work.
Right.
Right? Does it make sense?
Yes.
Okay, now where are we at here? It is, oh wow, we're fast.
Go up.
Okay, so let us turn in the textbook to page 145. Now let me check something real quick while you're getting there. I want to see what the assignment was. Oh boy, did I do that already? Okay, you're supposed to do in section 7, you're supposed to do 1 to 10, 2 to 10 even, okay? So we're going to do number 1, and then we're going to go to 2, and then we'll do the even ones after that. Okay? All right, so let's look at problem number 1. And again, the directions are to do the answers by Augmented Matrix on page 145. Okay, so problem number 1. See, I need to move this. Okay. Problem number 1 says 3x plus 8y equals 54, and then 4x plus 5y equals 38. Okay? Now, we need a 1. We need a 1. Anybody see a 1?
Yes.
Oh, one person does. Anybody else see a 1?
Yeah.
All right? Okay. Where's the 1 coming from? 4 minus 3. Okay? So, anytime that you have equations, right, the properties of equality say if you add the same number to both sides, if you subtract equals from both sides, if you multiply both sides by the same number, or if you divide both sides by the same number, you still have an equality. So all we're doing is we're saying that this number and this number are equal, and so if I add equals to equal, I still have an equation. So I'm going to change this equation by saying equation 2 subtract equation 1. So what is 4 subtract 1? Alright, that's my new 1. And I'm not going to put the x up there. What is 5 subtract 8? Negative 3. That's my new y. Now, 38 subtract 54. Calculator work. What is it?
Negative 16.
Negative 15? No, that's too big. Negative 16, isn't it?
She's just so smart. No, it's
She-
negative 16.
16, negative 16.
So don't even use calculator. How do you choose it so much better? See, I text too much.
Okay, all right. Now, and again, see, if you're doing this, what would happen if I were to use negative 15?
Then you would do all the math.
Everything else, the algebra would have been right, but the answer would have been wrong. Okay, that's the thing you got to be careful about. Okay, now I have a 1.
Yes, you do.
All right, my next step, what do I need next? Now, Ruben, this is important. What's the next thing that I have to do after getting the 1 if I'm going to use an identity? If I have a 1 here, I need to make the other equation a 0. So that means I need to make a 0 with this -4, or with this 4. So I'm going to multiply this top row by -4 and add it to the bottom row. Alright? -4 times 1 is a 0. I knew that. Now, what is -4 times -3? 12 plus 5. 17. I can do that one without the calculator. Okay? Now, the next one. -4 times 16. That one I can't do. 64 plus 38. 64 plus 38. Under 2? Under 2. Okay? Right? Everybody get that?
Yes.
6 is 102. Now, what does this bottom one say? This bottom one says what? This is x, right? 0x.
So y.
17y equals 102. Now, if the world is nice, this will be a whole number.
And it will equal.
What is 102 divided by 17?
6.
6. So it is, the world is nice. 0, 1, and 6. Y equals 6.
Oh, we did this already.
You and I did.
Yeah.
All right. Now I have a 1 here, but I need to get a 0 there. What am I going to do to this 1 so I can add it and get a 0? Multiply the row by 3. Very good. So what is 3 times 0? Plus 1. That's good. So I haven't changed my initial 1 that I need. Now, 3 plus -3 is 0. All right? 18 plus -16 is dos. Not negative, though. Positive. Right? Okay, so here is my identity matrix. X equals 2, y equals 6. Right?
Yes.
Okay? Now, okay, so what have you learned? All right? The important thing is we're trying to get the identity matrix, so we have to have a 1 and a 0 underneath it, or a 1 and a 0 above it. Right? And so after we get the 1s, then we're working on this 0, and then we work to try to get a 1 here so that we can get that 0. And the problems that you're working on, most of them will work out to be whole numbers because the book is nice.
Is it? No.
Okay? All right?
No.
Most of them will work out to be whole numbers. All right, now let's go to problem 2. Yes. Yes, quick. Okay. All right, problem 2. 2x, 4x, oh boy.
I know, it's just such a nice problem, isn't it?
All right, 2x. Y. 6846. All right, I can't do this using Augmented. I can't get a 1.
It says to use there's like no way to get a 1.
There's no way to get a 1 out of it. So what should we do? Use Kramer's rule.
It doesn't say you have to do it.
Yeah,
Well, it does in the directions.
Oh,
By augmented but there's no, see now why is there no way to get 1? Because these two are even, right? And the only, see, I could use the elimination method. I could multiply this row by -2 and get a 0. Yes?
Most of the problems actually, you can't get 1.
No, you can, in problem 3, you have a 7 and a 3. Multiply the 3 times 2, what do you get?
Oh, 6.
6, and 6 plus, all right, now that may be something,
Oh, we can do that with this one. No, just kidding.
yeah, we can. Multiply this by 2 and this by 3,
Yeah. Oh, yeah.
okay? Multiply the top row by 2, and I'll get 14. Multiply this row by 3, I'll get 15.
Okay.
And then so I'm going to take 3 times this, and then I want -2 to get the 1. Okay, so it could be done. All right. So this is 15 and -14, which is 1y. Now this is 6 and -8, which is -2x. And this one we're going to have to do by the calculator.
I just go
68 times -2
-136.
plus, I get 2
For what?
for the final. 68 times -2, 46 times 3. So this is 2. Yeah, 2 is right. 2 is right. Somebody said a big negative number.
That was just 68 times -2.
Oh, okay. Oh, I'm sorry. Okay. All right. Okay. So, all right. Aria, while you were gone, we found a 1.
Cool.
15 and 14.
Okay.
Okay. All right. So now that I have a 1 here, what do I need underneath it?
A 0.
A 0. Okay. Which one do you want to use? We can use either equation. I'd rather use the bottom and multiply by 5, right? Because I don't make as many mistakes multiplying by 5. So I'm going to take this row, multiply it by 5. All right, 5 times -2. 5 times -2. 10 plus 2.
12.
-8. -10. Sorry. -10 plus the 2, -8. Okay. Then 5 times 1. Whoa.
Oh, negative.
Should be -5. Math doesn't work. So then that makes this 12.
I knew it was 12.
Yeah, there you go. Alright. And then -5 times, and 5 is 0. And then -10 plus 46 is 36. Okay. Alright, now, do you notice 12 and 36?
I do know.
What is the greatest common factor? Well, so that makes this 1, 0, 3. What does that tell me? That tells me that x equals 3. Okay? Now, to get rid of the -2, I'll have to multiply this row by 2. So 2 plus -2 is 0. 0 plus 1 is 1. And 6 plus 2 is 8. Okay. Now let's go back to the original. What's 4 times 3 plus 7 times 8?
68.
All right. It will be 68, right? It's 12 plus 56, which is 68.
Oh, yeah.
Okay, and it has to work, but we're just checking to make sure we didn't make a silly mistake. Well, among the 7 of us, we shouldn't, should we?
No.
Okay? All right, so, questions? Questions. Easy, hard. On a scale of 1 to 10.
10.
7.
10 is impossible?
5. Like a 6.
Negative
All right,
5.
6. Okay, is this math work? Oh yes, this is work. But the question is, does it make sense what they're asking you to do?
Yes.
Okay. All right, so what are we trying to do? What is this called, Hannah? This is an identity matrix so that we have one X and one Y, because that will help us with the solution. Okay? All right? Okay, let's go to 4. Let's go to 4.
We can make a 1 out of this one though.
Yeah, this one's easier, isn't it? Yeah. And so we have 9x plus 2y. Okay, now here's a question. Here's a question. And when I was teaching augmented matrices in Algebra 3, where it's 3 by 3, this makes much more sense. But how do I get rid of the x's if I wanted to?
Multiply the bottom equation by 2.
Very good. Actually, multiply the bottom equation by -2 and add it to the top, and I'll get 1x. Okay? But because this one is faster to see, we would probably start with this one first and look for the 1 in the second equation. All right, so what is 3 subtract 2? Is 1. Okay? What is -5 subtract -16? It's positive 11, right? And then what is 4 subtract 9? -5. All right? Now, so now I have this. What's the second step? The second step is I have to get a 0 in the same column.
-16 minus 5 means -2.
It's -5 minus -16. Okay? All right, now, how do I get the 0 up here if it's a 2? I multiply this equation, this new equation, by -2. Now, doesn't matter which ones I use because each of the mathematics is independent. So what is -2 times 11? -22 plus -16 is -38. All right? -2 times 1, -2 plus 2 is 0. -2 times -5. 10 plus 9 is 19. Now I know that one. You know what 19 times 2 is? 38. So what is... So this will be -2, right? So now I have 1, 0, and -2. When I divide everything by 19, and then I have -5, 1, and 11. Now, what's the last step? This is not yet an identity matrix, is it? Because of what?
Because of the 5.
5. So to get rid of it, I'm going to multiply the top row by 5 and add it to the bottom row. So 1, 0, -2 is still good. 5 plus -5 is 0. 0 plus 1 is 1. And this is -10 plus 11. Okay? And so what does the identity matrix tell me? That x equals and y equals.
1.
Okay? Now, making more sense?
Yes.
All right, does it work? Yes. But this is school work. Okay? So get used to it. All right, Ruben, you okay?
I am beautiful.
All right, okay. Did you write this down?
Yeah.
What do you mean, yes?
Yeah, I wrote down some of it.
What? Okay, you're missing, this is your first day, we'll have to talk about that. Yes, ma'am?
So is y equal -2?
Okay, wait a minute. This is the x, this is the y, and this is the number. All right, so 1x plus 0y is equals -2, so x equals -2.
Because y just kind of cancels itself out.
Right, and then this is 0 x's plus 1y equals 1, so y equals 1.
Oh, okay.
All right. It's good, and this is like shorthand, right? This is like shorthand, but if we were working these in class and you had to write those x's and y's and pluses and stuff, it would take you a lot longer to do this same problem.
Right.
The math would be exactly the same, but what you wrote down, you'd have x's and y's all over the paper, and when we get to the 3 variable, you'll have x's and y's and z's all over the paper. Right? So this is just a shortcut way of being able to do the math without having to write all the variable numbers or all the variables each time we do it. Okay? All right, now, what time is it? It's 10:20. All right, so we're almost done with class. All right, any questions on this? Okay, now let's turn to the next section. All right, now this is where we're going. Turn to page 147.
Oh.
All right, now again, don't freak out. Don't freak out. On page 147, the first column of numbers is the x. What's the second column of numbers? The y. The third column, z, and the fourth column is the numbers. Okay? Now, the problem with trying to do Cramer's rule is Cramer's rule for a 3 by 3 is a longer equation than it is for the 2 by 2. Right? And so the reason for learning Cramer's rule on a 2 by 2 is that it's relatively quick. And if you don't see how to eliminate, like that first problem where we had to get the 14 and 15, right? I didn't see that initially, and so what I would want to do is go straight to Cramer's rule because I know that works, right? But in a 3 by 3, you can use Cramer's rule, but the skill is much longer. The mathematics still goes in the calculator, but to do it correctly, the equation you put in is not A times C minus B times D. It's a longer equation. Now, you're not going to get into that. I can't remember whether they skipped that in this class or whether or not it comes 2 weeks from now. It may come 2 weeks from now. All right, but so this one, because it's a 3 by 3, you're going to have to get an identity matrix that looks a little bit different. The identity matrix is going to have 1, 0, 0 number, 0, 1, 0 number, and 0, 0, 1 number. Okay? And this is what we started with. Once we find the 1 for the x, right, then we're going to create these 2 zeros, right? And then we have to find a 1 for the y between these 2 numbers. These 2 equations have to create the 1 for the y. All right, and then you'll be able to eliminate the 1 above and the 1 below. Right, okay? So that's where that goes, okay? But that's coming up. That's not this week's assignment. This week's assignment is working with Augmented Matrix where you have just x and y. Okay? And I hope that makes sense.
Sounds good.
All right? Okay. Good job.
Thank you.
Thank you.